Okay, we are going to go ahead and get started with today's presentation. So I want to welcome everybody to spend a few minutes this afternoon in the Eastern time zone with us, in the morning still in the rest of the country. Just want to go ahead and welcome you to a presentation about SolidWorks and its use in research licenses. So I want to go ahead first here and bring in Pam real quick. So we're going to be going over this together, and she's going to get us kicked off.
Good morning, everyone. I'm glad you were able to join us either on this live presentation or we will be posting it later for you to share with your colleagues. I just wanted to introduce myself. I know a number of you on the call. I'm the business and research and entrepreneurship specialist here at DASI Solutions. That means I get to work with our research departments as well as incubators, tech transfer offices, all the way through to our entrepreneurs. So it's my pleasure to do that. I started my first business when I was 26, but really when I was 13, I was already working in creative jobs for pay. So I've always had kind of the entrepreneurial spirit in me, as well as I love working with entrepreneurial companies and introducing them to others. So I invite you all to connect with me on LinkedIn and learn more about what I do. Thanks, Darren.
Yeah, fantastic. Now, I've known most of our customers out there. My name is Darren, and I've been here since the early days of SolidWorks, so I've had the privilege of watching the tool grow from a cute little product to really the vast and powerful ecosystem that we really represent today. And that's what a lot of these presentations are about, is really about letting you know what the tools are capable of, because it really is much more vast than you might be aware of. Now, with my years in the business, we do a lot of different things around here when it comes to using our technology, both professionally and personally. Now, I've been married about as long as I've worked here, and when I'm not at DASI, I'm usually using SolidWorks. I'm just doing it on my own time. I like to use it to design things, to make sure that I have a plan of attack, essentially just to get a good plan so that all I have to do is just focus on executing that to create whatever the final product is going to be. I really like to lay things out and just make sure that I've got that good plan. It really gives me a sense of confidence moving forward with anything that I do. And when I can see it in my mind's eye, then I really am much more careful, meticulous, and good at the execution of that tool. I really also like to rely on my 3D printer. In research these days, 3D printers are very, very powerful because, first of all, the prices come down to where they're affordable even to just individuals. The cost of consumables is less expensive. They're readily available through places like Amazon, and they allow us to go ahead and test and retest things with an insignificant investment in materials and time. So it really allows us to flush out ideas, have them right there in front of us immediately. And from a research and invention standpoint, entrepreneurship, it's a fantastic tool to get that idea right there out there for investors to go ahead and really be able to tangibly see. Now, I like to do projects that involve everything. So SolidWorks in my case is my facility, but I use it to make end-use parts mostly. So again, inventing things that really don't exist or ever will exist, but something that I maybe need to use to solve a problem. So that's really where I am, most suited when it comes to our business, and I'm both, inside the business and outside the business, a huge SolidWorks proponent. So we're going to give this presentation today. We're going to do this by splitting up between Pam and I a little bit, and I'm going to jump back and forth between SolidWorks. But mainly what we just want to do is really demystify what our packages are, because SolidWorks is sold in a couple of different bundles and is accessible to different groups of people. But it's really just a matter of really being aware of what's right for you. So that is really going to be our main focus for today. So again, welcome and thanks for your time. So what we want to do is really just get into the bones of the presentation here. If you join our YouTube channel, you're going to get a lot of this information, both this presentation as well as all of the other information that we create. And for us, it's about getting what we know out into the user community. And the more you know, the more powerful you become. And really, that just benefits the entire community as a whole. Now, when it comes to research licensing, there's a few different areas that we're going to cover specifically today, just again to give you those levels and show you a little bit about maybe what you didn't know about what SolidWorks can do. So we're going to start off with really what's the difference between education and research licenses. And for that, I'm going to go ahead and throw that back over to Pam for a few minutes.
Well, here I'm back with you, and I want to talk about some optimized collaboration tools that can be used through SolidWorks and the importance of this. A number of our schools have EDU packages, and that's fabulous because that means by the time people get to the research point, they're very familiar with all the uses of SolidWorks, but they've done that work on an education license that has a watermark. Our research licenses do not have a watermark. They come out at the same time as our commercial editions. I really say they are commercial licenses at research prices. So they're perfect for building value. I don't want to read to you. You can see that they can create intellectual property and public use in publications for documents and patents. Those are really, really important differences and three main things that an education license cannot do. These are really full commercial licenses, and you can use them as you wish. So we talk about investing in a research license, and it really is an investment. We know that if you create IP that's valuable, it's going to lead you to the next project, to new grants, to more pieces. It will allow you to stay right on track, to do your work quickly and convey ideas effectively. You really can do a lot with a little, and they say that really you can speed up your work by 80% using the proper tools. And we really know that the people who are using SolidWorks licenses know that. So how do you qualify for a research discount? The most important thing is the research license is owned by the university. That may mean your lead time is a little longer because you have to do a PO or go through procurement or your IT department. That's really key, and then you work out how a researcher or a lab works out how payment gets moved in between. These must be used by university students, faculty, or staff at all times. They cannot be used by regular commercial clients. The external deliverables are great. So that means if you're working on a contract for a company, doing research for the company, but the university owns the license, that's just fine. But an individual or a professor cannot get this discounted license. So again, the research license includes all intellectual property, and that's not in the EDU edition. So if you have more questions, feel free to reach out to me at the end of the program.
All right, thank you very much for that. So just dovetailing a little bit on what Pam just said, we've got some fantastic documentation we've created at DASI that really just lays this out for you. So reach out to us and we'll get this to you. So really the main bullet points that we have here, but this document that we've created really just lays it out very simply. We're talking about the biggest difference between educational and research. For a lot of us, it comes down to just simply cost, but cost and price are two different things really when it amounts to it. But when push comes to shove, compatibility with the commercial license is really what a research license is. It is commercial at your research costs. So that's a very important bullet point for us, which really leads me into another topic along that. Because the release cycle is identical to commercial, that means you have the same release cycle and the same what's new cycle. When it comes to EDU, we have to go with the school cycle because we can't change software during the curriculum year. So it has to be what's available when staff is preparing the networks and getting the school ready for start in April or August. So in October of every year is when we release our main commercial version. So effectively, an educational institution has to wait about 10 months for that. Now, some of the things that are really main highlights in this version of SolidWorks 2019 are what I really wanted to talk about here, because in reality, the presentation that I do about what's new in SolidWorks 2019 is 3 solid hours of very rapid presentation. So there's a massive amount of information that comes out. Research licenses get immediate access to that. So for just a little bit of a taste of really what you would get as it becomes available, one of the biggest things that really happened with SolidWorks 2019 this year was graphics performance. Now, the best way to demonstrate this is not necessarily to show you, files you're not intimate with. But really, in this case, I want to do a side-by-side comparison of the same data in the different versions. And what we did with graphics performance this year is we now use full video card graphical processors, the GPU. So instead of just utilizing the RAM and the memory of the card, we're actually utilizing it for performance purposes. Now, this is all related to OpenGL 4.5, which really just takes a driver update when you install SolidWorks 2019. Now, it works for both NVIDIA and AMD certified cards for SolidWorks. I just happen to be an NVIDIA user, therefore, when I'm looking at these types of things, I have that data more readily available to us. But this is really about 4 years back worth of video cards. So we're not even talking a new paradigm of graphics for just the latest and greatest hardware. It actually is for 4-year-old computers or so. So right there on that range. Get the new driver, turn on the switch in SolidWorks, and that will take care of it. Now, this is what we would have seen back in SolidWorks 2018. This is a very large model, but we utilize tools like large assembly mode, which is a way of decimating the details, as you see here, parts going cubic as you rotate and zoom, and then turning into full detail as you pause. Now, we don't have to do that anymore, because what really happened in SolidWorks 2018 when we went full featured, as we turn off now, is you're actually going to see the sluggishness that we would have experienced with a file of this size. Now, granted, this is around 11,000 components, but you get the jitteriness and the stutter that happens with that. And essentially, you see how it gets sluggish. Without any effective tools, large assembly mode or anything turned on, this is typical graphics in SolidWorks 2019. So as I rotate and zoom and pan, there's no decimation of details. And when I show you these two side by side with the same rotation of the same model, you can see just how smooth and clean it is on the right versus in SolidWorks 2018 on the left. Same model, same settings, different versions in the way we utilize the graphics. So really tremendous increase in graphics performance in this version. We don't decimate the details, we don't remove extraneous features or textures or light sources or shadows. It just works faster because we're utilizing the hardware better. Now with that, you can test your hardware very quickly just by running SolidWorks RX on your machine. And just by simply running the diagnostics, it'll let you know if you're in the right situation here with your graphics card up to date. I currently have a newer version that's 411.63. 390 and up are going to support this new set for basically every NVIDIA Quadro engineering version of the card. Now, silhouette defeature is another great thing that allows you to make detailed components, but when they're used in larger assemblies, we can manually get rid of the detail, still make it representative, but take a lot of the extra stress off of our video card. Now, the process works unlike our original defeature for imported data and existing SolidWorks data, but not just for scrubbing internal details. It enables us to look at parts and basically simplify them in the way the part is. So cylindrical for the motor that we see here, more prismatic for this electrical box, hexagonal or round, cylindrical for these parts, or even at the user's choice from different directions in the way that we would approach simplification of a part. It's a very easy and straightforward workflow, but allows for some really tremendous lightening of the graphics and the stress on your computer when these assemblies are used in larger assemblies where the detail isn't quite as necessary. The structure system is a brand new way to do weldments, and it doesn't replace the existing weldment methods, but it doesn't rely on sketches exclusively like the existing weldment methods we have do. This can use the edges of surfaces, sketches of course, and then the way that planes and points and sketch entities intersect each other as a method of defining different components, whether they're primary or secondary structures. It really is a different workflow, but uses the same libraries and the same support structures inside of our weldments library that we use in the regular weldments tool. So it's a new function for larger scale, rapid creation of really massive sized weldments. Multi-body interference. I wouldn't consider this earth-shattering technology, but when it comes to what it does for you, this is important. And it further narrows the gap between what we can do in an assembly file versus what we do in a part file. Now, multi-body is used primarily with things like weldments and sheet metal components, and it really makes a very rapid method of putting those types of structures together. But not being able to do a simple vetting of the parts, whether they interfere or not, was a restriction that we overcame with SolidWorks 2019. It's great to have that as soon as it's available. It enables us to see where we maybe have missed trims in a weldment or where we've overbent a sheet metal part and there's interferences on those situations as well. But it works for those areas that doesn't require you to make an assembly out of your file in order to test it. The last thing I'm going to cover here, really the top 5 that I have, is this really great thing we call 3D textures. Now, 3D textures are something we've always represented with graphics, but we can now take that graphic and using the grayscale, either bump or indent the white or black areas in contrast to create actual 3D mesh bodies. Now, these can be sent right to the 3D printer, and the texture you see is exactly what you get off of those manufacturing methods. It's really a tremendous way to, instead of faking something with graphics, actually putting in a real manufacturable type of texture like this knurling or like a diamond plating or something to that effect. On a surface. So really interesting things working with new mesh model paradigms that we started pioneering back in SolidWorks 2018. That also leads me to SolidWorks Extended Reality. Now, using e-drawings in SolidWorks 2019, we can now open up large-scale one-of-a-kind files, which is a great use for this because there's no other way to actually immerse yourself into anything that exists if it hasn't been created already. Now, using our direct VR, we open up a SolidWorks assembly, and using an HTC Vive headset, we can actually walk through this. Now, the scale of this observatory is massive, but when you open the file up in VR mode in eDrawings, really just connecting to the virtual environment and putting the headset on allows you to immerse yourself into this one-of-a-kind thing. Now, it's hard to teach somebody how to assemble something or feel how something is going to look if there's no other tangible examples of these. So these types of devices allow us to immerse ourselves directly into the facility using the standard SolidWorks assembly and the proper supporting VR or AR hardware. So really tremendous examples of where we're going with these. There's a lot of virtual reality and a lot of augmented reality also added on top of this extended reality type of feature. So pretty great stuff. Now that's going to move us over to our next topic, which really just talks about some of the things available inside of SolidWorks that really set us apart and are things that I find a lot of people maybe don't know are there and really can really gain a lot of value from. And these are our evaluation tools. Now these are some pretty typical ones, but I still like to show them because you don't know what you don't know, but you also might have forgotten just how cool some of these really are for you. Mass properties is one of the easiest. Tell the part what it's made out of, gives you the density. The rest is a simple button pick and far from the calculus that a lot of us learned back in high school and college. Gives us instant mass properties, center of gravity, surface area, and more. Now, draft analysis is another one of those that, when used in the right situation, can really open up a lot of doors to where your designs need to be modified or maybe changed altogether. That on top of thickness analysis are a couple of tools that come with every seat of SolidWorks that really enable you to look at your assemblies and the parts that you've built in a different way and have maybe a manufacturing outlook, not just a physical geometry outlook. We'll cover a couple of these here in just a second. Performance analysis has been in SolidWorks for a few years, and what it really does is it shows you a punch list of the things about your files that maybe are causing slowdowns, whether it's file open times, rebuild times, or graphics overhead. And then the measure tool. This one can never be used enough. Whether you're just a manager that's looking at the overall scale and footprint of assemblies, or whether you're a designer or a customer that needs to look at the intricacies of your parts in order to go ahead and physically manufacture or quote them, the measure tool is one of those that's very, very important. I'm going to jump into SolidWorks here for a second. First, we're going to hit thickness analysis. Now, this is a tool we simply click on our measure tools, on the evaluate tab. And what it will give you is a nice color-coded thickness analysis. Now, with plastic parts, what we're concerned about here is cooling temperatures and what's going to cool before another area, maybe where sink marks or other deformities might take place. So a thickness analysis in our situation allows us to hover over the part, show us whether we have a normal or nominal thickness, or whether that thickness deviates quite significantly in different areas. It's all about hovering over those areas. Now, we also use this with imported parts often to diagnose sheet metal issues, because if a part isn't constant thickness using sheet metal, it can't be unfolded. Though we can do that with imported data, it still has to be quality data. I also like to use draft analysis with any type of plastic injection molded part. With draft analysis, all you're really trying to show somebody is the direction the mold's going to open. So by simply using a plane in your feature tree, that's going to give you a nice color-coded part here that lets you know what has draft on the positive side, the negative side, or as a straddling face, as we call those. Straddle faces will go from one side to the other. Now what I see here is a yellow face, and in our key it shows that it requires draft. What that really means is it's less than the draft that we're actually looking for. So as I narrow that number, we can actually go down to 0 draft, and on a round part like this, it's really going to show us the silhouette from A side to B side. Now changing the direction of the plane there, if we simply look at it from the right side, really looks like this part could be made nicely as two halves, a lot of positives and negatives in the right directions. Maybe we'll take a look at it from the top. Interesting part about helmets like this is they are flexible on the bottom. If you've ever put them on over your head, this might actually be the angle of attack that's the desired design. Should pop right off the bottom molded tool and maybe be able to get that core right out of that cavity. Either way, this lets the designer know that maybe there's some changes that have to be made based on restrictions in their manufacturing capabilities moving forward. Performance analysis is one that I typically use when I'm looking at an assembly. Now, what I typically use it for is some of the low-hanging fruit, maybe graphical stress, imported parts, and definitely rebuild time. So by going to your Evaluate tab and simply clicking on Performance Evaluation, that's going to give you a really quick list here that shows you the open times and which is the worst offender on the files that you're looking at. Now, if you scroll down a little bit further, you're also going to get a list of the graphics triangle overhead, which is essentially what your video card sees. The parts are built by little triangles in space. The smaller the triangles, the more round your part can appear. Now, if you want to physically show what these assessments are actually talking about on your parts, all you have to do is toggle this button called Assembly Visualization. And what it will essentially do is color code your assembly on screen and show you, based on your sort order, what those offenders are and color codes them directly for you. Now, what I like to do is basically vet this part based on whatever I'm looking for. In this case, let's just call it graphics triangles. Right now, I'm looking at about 52,000 triangles for this top offender. Now, what I used to do is basically go ahead and just take my sliders and just drag them around so that I have these very discrete color areas. If you take your red one down, you're going to have red and blue side to side, and you're going to have all these solid red ones above and blue below. Now, you can also go ahead and actually take these components and simply select those. What I like to do here is take this and do an invert select, and then when it picks everything else, I'll just right-click on one and say Hide. This actually tells me what that first line looks like. And in my case right here, it's going to show us that it's all fasteners. Now, this is one of the things that might be a little bit of a misnomer when you look at this. We're talking graphics triangles, and 52,000 is a lot for a part. But the reality of this is it's actually the cumulative here for the quantity of 40. If you toggle this button here, you can look at things ungrouped, and that would essentially show you that each one of those individual fasteners really isn't so bad on its own. But it does also show you that fasteners add up, and a lot of those fasteners are going to give you tons and tons of triangles as a result. So there's many ways to go ahead and use this tool to go ahead and locate and visualize what you see on screen, and maybe based on a sort order of open times, rebuild times, or any other property that you might want to go ahead and fit into this, you can go ahead and use this tool to really demystify who in your assembly is actually causing the most overhead or whatever problem really you're trying to figure out. Now, regardless of the ones I just showed you here, really that's just the tip of the iceberg. These are 5 that I use quite often, but in reality, there are so many more of these. I can't even cover them all in an hour. Now, on top of what you see on the screen, there's basically 20% more than what I could even fit on here. So there's a lot of great evaluation tools. They give you information about designs, parts, and tooling that really doesn't even have to exist anywhere but in your computer. So I can't stress just how powerful these things are for getting a lot of value out of a pre-design that really doesn't have to have any tangible goods produced until you're really ready to move forward. Evaluate, super essential. Now, the next thing we were going to talk about, and really I'm not going to spend a ton of time on this because we've got some great information that you can just look at for this, is what's the difference between a SolidWorks standard, professional, and premium license? We get this common question quite often. Now, it's the only 3 bundles we have, but the reality is, how do they packages differ? Well, it's really just one thing: productivity tools. Now, when I talk about productivity tools, usually my best example of this and how the packages have changed over the years is a little thing that we call internally the waterfall effect. Now, every once in a while, SolidWorks will go ahead and take a tool that maybe isn't as accessible to everybody based on the packages they own, and they're going to drop it down into a more accessible environment. So when we talk about this, I'm going to go back to around 2014 when we had a significant bout of these. Now here we're looking at the standard productivity tools that were in each of these products, and you'll see some labels for these at the end. But they're things like Scan to 3D, CircuitWorks, this is sustainability, and PDM, and then we get into some utilities like FeatureWorks and costing. Now these types of things were sitting in these bundles, either separate purchased or part of premium or professional. Now when we moved from SolidWorks 2015 to SolidWorks 2016, we had a little bit of a waterfall. We had Sustainability moved down to premium. We had CircuitWorks move down to professional, and then a few new products that came in, like our model break view and our flattened surface tools. From 2015 to 2016 was the most significant change here. So as I click this one through, watch everything that drops. Basically, the tile analyst and scan to 3D slid down to professional. A lot of things now turned into regular standard features like model break and feature works and utilities. And then we added part costing down to professional, moving assembly costing up. So this is really where things sat as of 2016, and for the most part are still very similar to that. But the important thing there is that you choose the bundles that are important for you based on what you need. And there's always a way to go up to the next level. But in this case, we try to bring products down to people as we hit these tipping points. Now that said, we're talking about what's happening with these different productivity tools. What we're really talking about is simply the add-ins tool inside of SolidWorks. So if you go to the tools pull-down menu and down to add-ins, what you're going to see is a list of those things that are part of these products. Now mine lists as premium since I have a premium license. If this was a professional license, it would knock out just a couple of these little things. Things like the higher end SolidWorks simulation, SolidWorks motion, those don't show up in professional. But for more information on this one, instead of just trying to show you everything that's here, we've got a document for you. But basically it lays out where our circuit board reading tools are, where our feature recognition is, and where things like our photo rendering tools, both photo view and visualize. Those are both in professional. And you get some things like a motion kinematics and assembly simulation and routing. Those types of things show up there in premium. So to get really a big list or good layout of this, just go ahead and hit the DASI Solutions website. We have a giant matrix here. In fact, if you go ahead and just follow to the DASISolutions.com website, or look through the documentation I was referring to earlier, the PDFs that we have, what you basically have under our solutions pull-down page is the ability to choose what solution's right for you. Now, the reason I didn't want to necessarily show this on a slide is because this is a pretty vast matrix. Now, the list itself is quite huge, so obviously we're not going to cover each individual part of that. But often what you're going to see are these tiny little play arrows. And if you go ahead and start grabbing and clicking on those, that's going to drill you down into a video or some other thing that's going to show you more information about each and every one of those little details. So we rely on some of our SolidWorks friends like Todd and Brad, and then we go ahead and put our own videos up there for other things to supplement. So you're going to see a lot of faces up there, but when you want to know a little bit more about sheet metal design, go ahead and click on it. You might get a buyer's guide, you might get a tutorial, you might get a blog or a video. But there's a great amount of information right from this matrix. So hit our website, and that'll give you a lot more information than I can jam into a really short presentation here. The last thing I'm going to throw out at you here is another benefit, and it really doesn't matter what level of SolidWorks user you are. You can always get better access or more comfortable access for the type of way that your brain thinks. So I want to show you a little bit of customization that we do inside of SolidWorks just to make accessibility to buttons and tools just the way that you want it to be. Now we talk about four main things here when we choose a customization that's better for all of us. Most users default to the command manager. That's going to be the tool set that's tab-based, fully customizable, and it's usually across the top of your interface when you start a new session of SolidWorks. Now the right mouse button for Windows users is probably one of the bigger things. When you right-click, it's context sensitive, so what you right-click on or where you right-click has everything to do with exactly what you're going to see on that menu. Power users start to memorize these menus, we start to add things to them, remove things from them as necessary to make them just as efficient as they need to be. I'll go into each one of these in just a moment. Gestures is a great tool. This is a right mouse click with a swipe involved, so it's a pick and drag. But it gives you a fully customizable set of tools in 4 different environments, depending on what you're working on, that really give you access to those really quick tools, the main ones that you want, and even some other ways to get to some deeper depth to our toolbars that I'm going to show you in a moment. And then there's the shortcut bar. Now this one's the S button on your keyboard. If you type S while you're working in a part, assembly, drawing, or sketch mode, you're going to get a toolbar that pops up directly at your cursor position. Now what that enables you to do is put any buttons that you want on there above and beyond the default buttons. You can load these up with buttons so that effectively you don't have to move from the center of your graphics area. So over to SolidWorks real quickly here. Let's hit each and every one of those. The command manager obviously is clear here across the top. Now this is tab based. It's going to be there based on whether you're in a part, assembly, or drawing mode. And by switching from one mode to the other, what we essentially get is a changing of those tabs based on the type of mode that you're in. Now, if you find that you're missing a button, maybe you come to a What's New presentation and you found out, hey, we've got this brand new thread tool. Go to the upper right-hand corner to your search and simply go to the command search and type whatever, THRE, a little bit of a wildcard of what the tool you're looking for is. By clicking on the tool, you can run it. By clicking on the eyeball, it's going to show you where it is on your toolbars already. And if it's not there, you can simply pick and drag it to your toolbars. So customize as you need. Now, there may be buttons here that you don't need, like this extra thread button that I just added to my tools. Well, without having to be in any type of customization, just hold the Alt button down on your keyboard and pick and drag to remove that button from your interface. Simplify things, get rid of buttons you don't use, and get rid of eye clutter. Make it efficient. Now, the right mouse button is a very important thing. Depending on what file you're in or what situation you're in or where you click, you're going to get a different menu. So if I right click on a part, I get access to details of the part, the sketches and features, and everything about that component or the features or the faces I've clicked on. If I right click in the graphics view, I get zoom, rotate, and pan. And if I right click on the toolbars, I get a list of available toolbars. The right click menu is one of the more powerful ways to interface with any Windows software, and SolidWorks takes it to the next level. Now, these menus have gotten large. In fact, I'm on a pretty high resolution monitor, and what you'll see at the bottom is that my toolbars show a double arrow. Well, this is the initial right click. If I simply follow that double arrow down and click it, what it does is it gives me the full right click, which as I scroll with my middle wheel, shows me that that's a pretty lengthy toolbar. At the bottom of any extended menu, you're going to see Customize Menu. This enables you to actually choose what you see on the initial right click and what you don't. So if I don't want to see Make Virtual, I'm going to turn that off. That way, the next time I right click on my part, you're not going to see Make Virtual there. But if I do happen to go ahead and hit the double arrows and fully extend it, you'll actually see Make Virtual then show up as the secondary menu. So that's the best way to customize your right mouse menus. Gestures and shortcuts are really quick tools. By hitting the S button on the keyboard, I'm going to get, in this case, an assembly mode toolbar that pops up. If I happen to go ahead and edit a part, which I'm now in edit part mode, S button gives me a whole different set of things, and in this case it gives me feature tools. So it's a super powerful function. Now that, coupled with my right click and drag, gives me my gesture rings. And here I actually have 8 commands where I can simply swipe and get to a different viewing position, or I can swipe down and actually bring up my shortcut tools because I'm lazy enough that I don't even want to press the S button on the keyboard. So there are very quick ways that you can go ahead and access these tools. Now, by right-clicking your toolbars and going to Customize, you can customize any one of these different areas. So all of your shortcut bars have the ability to be simply clicked and have buttons added to them by just dragging them over, and now you've added information to those toolbars. If you click on your menus or your commands, those enable you to give yourself different toolbar settings. Keyboard shortcuts, if you're an older AutoCAD user, you really might love these. You can even print the entire list and show only the commands that actually have keyboard shortcuts to really simplify what you're seeing on screen. And then the gestures pop out with these different rings. With this, you can choose any tool that you might want. So maybe I want to go ahead and close files with a pick and drag to the left. And if I want to put that on all my toolbars, I can actually use a simple control pick and drag, which is a Windows copy. We can copy buttons from one tool set to the other. These can be shown as little as 2 and as much as 12 gestures. So by clicking up to 12, we can have many, many more options. And basically every 45 or 60 degrees, you're going to have a different swipe. So pretty interesting ways to access tools in SolidWorks. I like to use the gestures quite often, like I said, just to swipe down and even pull up my toolbars for my quick S key commands as well. So those are some of the ways that I like to use SolidWorks and some tools that I really find to be really the things that you should jump into immediately when you do get a new research license of SolidWorks. So Pam, do you want to jump in and do any type of closing?
Well, first of all, thank you, Darren. That was great.
Yeah, you're welcome.
I always like learning. I may not be able to do all the work that you guys can do in SolidWorks, but I always enjoy picking up the pieces so I can tell you about the new and important things. The only thing I want to add is that anyone who has one of our research licenses can also use our tech support system here at DASI. And that is really key. Our folks are fabulous, and what they really want to do is help you. And they're challenged when you're challenged. So feel free to put in a help desk ticket or let us know in any way. You can send me an email and I'll set up a help desk ticket for you. Don't get embroiled in a mess. Get help through your DASI support team and move forward faster. So that's what I have to say for today, except thank you. We hope that you'll share when this goes onto a recorded session. We hope you will share this with the researchers at your university and with all your colleagues. So thanks again, Darren, and thank you to everyone.
Thank you. Thanks everybody for your time today. We appreciate it. Take care. Enjoy the rest of your day.